Today we are going to discuss Bohr's atomic model. We'll discuss what were the details of the Bohr's atomic model, and then we'll apply Bohr's theory for atomic model to a hydrogenous atom. And from that we'll get the expression for radius of the orbit of the electron, also the velocity of the electron in a particular orbit, energy of the electron in any particular orbit, and also the energy of transition. So let's take Bohr's atomic model. Bohr has assumed that in an atom there is centrally situated nucleus where whole positive charge and almost entire mass of the atom is concentrated, and the electrons revolve around the nucleus in circular orbits. Basically, he has retained two parts of the Rutherford's atomic model. So he has used the Rutherford's atomic model concept of the nucleus and the motion of the electron around the nucleus there in circular orbits. But then he modified that in Rutherford's atomic model, where Rutherford has said that electrons are orbiting around the nucleus in the different circular orbits there, where its centripetal force gets provided by electrostatic force of attraction. Bohr has assumed that any particular orbit is not possible. There will be certain selected orbits only. And as long as the electron is in that particular orbit, it will neither radiate energy nor it will absorb energy. So Bohr's atomic model is that there is centrally situated nucleus in an atom where whole positive charge and almost entire mass of the atom is concentrated. This is one which is taken from Rutherford's atomic model. Electrons revolve around the nucleus in circular orbit. This was also taken from Rutherford's atomic model. But then he has made one restriction, that only those orbits are possible in which angular momentum is integral multiple of h by 2 pi. So he has used basically the concept of the quantum theory there. Angular momentum mvr, this should be nh by 2 pi. M is the mass of the electron, v is its velocity in particular orbit of radius r, h is the Planck's constant, and n is principal quantum number. So it's not that electron can revolve in any particular orbit, it will be revolving only in that particular orbit where its angular momentum is integral multiple of h by 2 pi. Another point was there that as long as the electron is revolving in any particular orbit, it will neither radiate energy nor it will absorb energy. And when electron make a transition from one orbit to another, it can do so only by absorbing or radiating suitable energy, which is given by Em difference En equals to h nu. Em and En will be the energy in the mth and nth orbit there. So only if they get the energy, which is basically the difference of the energy of the two orbits, either it will absorb that one or it will radiate. When it will absorb, it will move from lower to higher energy state. And when it is radiating it, it will move from higher to lower one. So this is possible only when there is the energy associated, which is given by this expression. So he has basically used concept of the stationary orbit there. That means once the electron is revolving in a particular orbit, it is neither radiating nor it is absorbing any energy there. And there the orbit which is possible, it is one where angular momentum is integral multiple of h by 2 pi. Let's apply Bohr's theory to a hydrogenous atom. That means we are taking a hydrogen type atom. That means the atom in which will have one electron in the outermost orbit. Like if you have suppose hydrogen, or you have He plus, so it will have one electron in the outermost orbit. It may be your lithium, it may be your sodium, or it may be your Mg plus. Of course, as long as you are applying it to the simple atom which is similar to the hydrogen there, in that case the results will be almost same and then its actual values. more complex atoms are there, in that case there may be variation. So it is basically there, we are applying it for the simple hydrogenous atoms there. So suppose we have an atom whose atomic number, we are taking it as Z. So in the nucleus there will be positive charge Ze, and the electron is revolving in a circular orbit of radius r. R is the radius of nth orbit, suppose we assume. M is the mass of the electron, E is its charge, and it is moving with the velocity v. So we are taking M as the mass, E as the charge, v is the velocity of the electron, r is the radius of nth orbit of the electron, and on the nucleus we have the charge as plus Ze. Z is its atomic number. So electrostatic force of attraction, electrostatic force will be 1 by 4 pi epsilon naught Ze into E by r square. If you consider the centripetal force will be how much? mv square by r. So in equilibrium, this is equals to 1 by 4 pi epsilon naught Ze square divided by r square. This is your mv square by r. Or we can get r equals to Ze square by 4 pi epsilon naught mv square. This is suppose our first equation. We are basically trying to get the expression for the radius, for the velocity, and the energy of the electron in the hydrogenous atom. So this is the expression for r. From quantization of angular momentum, what will get? mvr equals to nh by 2 pi. So we can get the expression for r as nh by 2 pi mv. This is our second equation. Now from first and second, if you compare, so from equation 1 and 2, if you compare, what you will get? Ze square by 4 pi epsilon naught mv square, this is equals to nh by 2 pi mv. We are equating equation 1 and 2. So from this we can cancel this m, 2 pi we can cancel, and we can get the expression for v, which is your Ze by 2 epsilon naught nh. This is the expression for velocity there. So suppose I call this as equation 3. So this is the expression for velocity of the electron in nth orbit. Now if I put this value of v in any of these equations, we can get the expression for r. It is more convenient and easy to put it in equation 2, because here it is in the first power, here it will be a square there. So putting in equation 2, r will be nh by 2 pi m. For v we are putting this term, Ze square by 2 epsilon naught nh. So this is your n square h square divided by, of course epsilon naught will come in the numerator, this 2 will get cancelled, pi will be there, and then it is your m Ze square. So this is the expression for r, that is your epsilon naught n square h square by pi m Ze square. This is the expression for r, that is the radius of the orbit. So this is the expression for velocity, this is the expression for radius of the orbit of the electron. For the expression for energy, if you take electrostatic potential energy, This is how much? 1 by 4 pi epsilon naught Ze into minus E divided by R. Just like 1 by 4 pi epsilon naught Q1 Q2 by R. Then kinetic energy. This is your half mv square. Now here for half mv square, we know that we have electrostatic force as mjd square r square equals to mv square by r. This we have done. So from here, what we can do, suppose if I take that this r is getting cancelled, so we have Ze square by 4 pi epsilon naught r. This is how much? mv square. Suppose I multiply both sides by half. So now what is this? Kinetic energy. So the kinetic energy we can write as Ze square by 8 pi epsilon naught r. Potential energy we have taken here. So the total energy if you take and represent it as E, this is electrostatic potential energy plus kinetic energy, which is equals to minus 1 by 4 pi epsilon naught Ze square by r plus 1 by 8 pi epsilon naught Ze square by r from kinetic energy. What we get here? Minus 1 by 8 pi epsilon naught Ze square by r. Now we can substitute the expression for r here. So putting for r, E will be minus 1 by 8 pi epsilon naught Ze square. For r we are putting this epsilon naught n square h square pi m Ze square. So this is your minus Ze square whole square. Then it will be your 8 epsilon naught square n square h square. Of course, this m will also come in the numerator. So this is the expression for energy of the electron in nth orbit, which is your m Ze square whole square divided by 8 pi is getting cancelled, epsilon naught square n square h square. Now you can see here that this term like m, z for a particular atom, E, epsilon naught, h all will be constant. So this E is your minus E naught by n square. If you consider, suppose Z is 1, like for a hydrogen atom, if you are taking, in that case, this will be, Z will be 1. So there you can substitute for that. That means what you can basically observe that E is inversely proportional to n square. So if number of orbit is increasing, this is inversely related, but it is with negative sign. Don't forget. So that means as the number of orbit will increase, the energy will go on increasing. So this is the expression for the energy of the electron in any particular orbit. Let's take energy of transition. That means we are taking that electron is making transition from N1 to N2. N1 orbit to N2 orbit. So the energy of transition, this will be the difference of the energy. So it will be your energy in the final orbit to the energy of the initial orbit. So it is your En2 minus En1. So if you substitute that, what you will get here? It is minus mjd square whole square divided by 8 epsilon naught h square, epsilon naught square, and then it is your, this will be N2 square minus N1 square, because it is your 1 by n square. Negative sign we have already taken common, so it is for the final orbit energy to initial orbit energy. So this is 1 by n2 square minus 1 by n1 square. This is the energy of transition whenever electron makes a transition from one orbit to other there. So with that you can easily calculate. Let's now take drawbacks of Bohr's atomic model. First drawback was Bohr's theory or Bohr's atomic model there, it is applicable only for simple hydrogenous atom. Bohr's theory is applicable only for simple hydrogenous atom. It fails in case of the complex atoms or multi-electron system. So that was the first drawback, applicable only for simple hydrogenous atoms. And it fails in case of complex atoms and multi-electron system. Second was there could not explain a Stark effect. That means it could not explain splitting of spectral lines in electric field. That is called as the Stark effect. So this could not explain a Stark effect. The Stark effect is splitting of spectral lines in electric field. Then it could not explain Zeeman effect. That is splitting of spectral lines in magnetic field. So this is also one of the drawback of the Bohr's atomic model there, or Bohr's atomic theory. Next is there, Bohr has assumed that as long as the electron is revolving in a particular orbit, it is neither radiating energy nor it is absorbing energy. But why it is so, he has not explained that. He has just said that it will be not radiating nor absorbing energy there as long as it is in one particular orbit. So this is also another drawback. It could not explain the variation in the intensity of the spectral lines there. So this is also another drawback of this Bohr's atomic model or Bohr's atomic theory. So these were some of the limitations of Bohr's atomic theory. But still it has the importance. It was the first one, first basic theory to give the details of the atom there, and especially like the for the expression of the different terms involved there, like for the velocity, radius. Even if it is there for hydrogenous atom, at least it gives a proper foundation there.